All right, guys. Hopefully everybody had a great Thanksgiving holidays. Be looking forward to seeing you back after the distance learning. So you had the schedule for what we're going to plan on doing before our exams. So today I wanted to review over graphing rational expressions. We talked about this a couple of times already. So I have some examples up here for you to do or to go over and how to graph them. And so we're going to start off with number two. They ask you what is the domain and to describe the graph at where the domain or at the values that are not in the domain. Well, the values that are not in the domain is just our vertical asymptotes. So here we get negative 3 over x plus minus 1. We know that the denominator tells us vertical asymptotes. Numerator tells us zeros. Leading terms tells us horizontal asymptotes. This is our graph. So my domain is negative infinity to 1 and 1 to infinity. So it's undefined at 1. So I have a vertical asymptote at x equals 1. So as I graph this, I have a vertical asymptote at 1. I have a horizontal asymptote at 0 because, again, my leading terms, negative 3 over x, any form of 1 over x tells me a horizontal asymptote. If I put a large positive number in here, that's going to be, the denominator is going to be positive, numerator is going to be negative, so I know I'm below the x-axis, negative over a positive. So here's my graph, gets close and close, and my y-intercept is 3, so I know I go through 3, so here's my graph here. So what they're asking you to do, at the extremes, as x approaches infinity, this is how you write it. Okay? Limit as x approaches infinity. As I go right as far as I can go. What is my graph doing? My graph is getting closer and closer to 0. Alright? So when they limit, they're looking for the vertical. Where is it getting close to? What level is it getting to? What floor is it getting to? So as I follow my graph, as I go toward infinity, my graph is getting closer and closer to 0, but never touch. As I go to negative infinity, where's my graph going? It's getting closer and closer to 0. My end behaviors, right, should be getting closer to my asymptotes, my horizontal asymptote or my oblique asymptote. All right? But what they want you to ask to do, what is the behavior at the vertical asymptote? This is how I write it. The limit of f of x as x approaches 1 with a superscript of plus. That means coming from the positive side. So coming from the positive side to my vertical asymptote. Coming this direction. Where's my graph going? It's going down. Negative infinity. Then what's the limit as f of x as x approaches 1 from the negative side? So I'm coming from the left. Where's it going? Follow my graph. It goes to the positive infinity. At every vertical asymptote, I have two limits. One from the right, one from the left. I'm going toward my vertical asymptote. One from the left, one from the right. And this is how I write it. So this is what they're looking for when they ask you to write the behavior of the graph at the vertical asymptotes, or at the values that are not in my domain. Values that are not in my domain, vertical asymptotes. That's what it is. Number 10. Here's my function, 4 minus 3x over x minus 5. They ask you, how does this graph get transformed from this graph, 1 over x? Remember, 1 over x looks like this. All right, how did this graph change to this? Well, if we go ahead and graph it, vertical asymptotes, x equals 5. Horizontal asymptotes, leading terms, negative 3x over x, y equals negative 3. Y-intercept, put 0 in for x, 4 over negative 5. Correct? So I got negative 4/5. All right? And my zeros from my numerator, 4 minus 3x equals 0. Negative 3x equals negative 4. X equals 4/3. So 4/3. So here's my 0, 4/3, 1 and 1/3. My horizontal asymptote, y equals negative 3. Vertical asymptote, y equals 5. My y-intercept, which we said was negative 4/5, right there. Here's my graph. Put a large positive number in. All right, negative over a positive, so down below. I know I have to go through these points, so I have to come through this point and through this point. All right, so there's my graph. Well, if they want the transformations, I have to go ahead and divide denominator into my numerator. So that's what I did. X minus 5, x goes into negative 3x, negative 3 times, negative 3x plus 15, negative 11 over x minus 5. So here's my graph. What happened? I subtracted 5 from the x, moved right 5. I negated the function, reflected across the x-axis. I multiplied, how did I get from 1 to 11? I multiplied by 11. Vertical stretched by a factor of 11. And then what did I do? I subtracted 3 from the function, moved down 3 units. So if I look at this graph, you see I reflected, I moved to the right, I moved down, and this just stretched bigger. So that's what we're doing. So to be able to do the transformations, I have to divide the new denominator into the numerator and get a function that looks like this, 1 over x. Here's my 1 over x. My 1 changed to 11, my x changed to x minus 5, and it changed to negative, and I subtracted 3. So there's 4 transformations. Follow from the inside out. Subtracted 5, so moved right 5, reflected, stretched, and then moved down. Okay? And that's what they're asking for when they ask, how did this function change from this function? So they're looking for the transformations there. And this is what my answer is. Now, if they were asking for this, my limits, there's my vertical asymptote at 5. It would be the limit as x approaches 5 from the positive side of f of x. From the positive side, coming from the right, where's my graph going? Down. Negative infinity. The limit as x approaches 5 from the negative side. That's coming from the left. Where's it going? I'm going up. Positive infinity. If I wanted my end behaviors, the limit as x approaches infinity of f of x. Is that going to the right? Where is it going? It's going to negative 3. Going to the left, negative infinity. The limit as x approaches negative infinity of f of x. Going to negative 3. Always going to my positive, my horizontal asymptote. All right, let's move over. All right, number 28. Again, we're going to get all our information. I get vertical asymptotes at 2 and negative 2. If I look at my numerator, if I cannot factor it, use the quadratic formula or use your calculator to find your zeros. My zeros are negative 1.84 and 2.17. My leading terms, my horizontal asymptote is y equals negative 3. My y-intercept, put 0 in for x, get y-intercept equals negative 3. So I plot here's my vertical asymptotes. Here's my horizontal asymptote, my y-intercept, here's my zeros, and here's my 0. Now remember what I said, when we have a 0 or a y-intercept on a horizontal asymptote, it's going to cross it. My horizontal asymptotes are for my end behaviors at the extremes. Large positive number, negative, over a positive. All right, I should be down to the negative side. But this 0 tells me I have to be up in this quadrant here. So here I'm negative, and over here I'm positive. So that way I know that I have to go through this 0. So I know I'm here and not here. Okay? Remember what I said. All right? We're crossing a vertical asymptote. So what do? I cross a horizontal asymptote. I'm up, so I'm down, because my multiplicities are odd. X minus 2 and x plus 2. I only see them once. So I'm down. All right, I got to go through this y-intercept, and I have to go through this 0, so I curve this way, sort of like the S curve. Okay? Cross the asymptote, I'm up, so now I'm going to be down. and there's my graph there. All right, so it always alternates unless I have an even multiplicity. And again, if I was writing my limits, the limit as x approaches 2 from the positive side of f of x, I'm sorry, this is g of x, equals infinity, the limit of g of x as x approaches 2 from the negative side. All right, from the negative side, I'm going down. Normally, unless my multiplicity is even, they're always going to be opposite. And again, at every vertical asymptote, I have 2. So here, the limit as x approaches negative 2 from the positive side of f of g of x equals positive infinity. The limit as x approaches negative 2 from the negative side of g of x is negative infinity. The limit as x approaches infinity of g of x, as I go on out, where's it going? It's going to negative 3. And the limit as x approaches negative infinity of g of x is going to negative 3 as well. So there's my end behavior limits at the ends. Here are my limits at the vertical asymptotes. This is how I write it. All right, people try to write it their own way. No, this is the way you write it. The x approaches is always under the limit of g of x. And then you have your answer to that. Okay? Next one here. Do remember, when I have the numerator degree higher than my denominator degree, I don't have a horizontal limit, a horizontal asymptote. I have an oblique asymptote. So again, I factor x minus 2, x plus 1, zeros are 2 and negative 1. My y-intercept, put 0 in for x, negative 2 over negative 3, which is 2/3. Vertical asymptote, x equals 3. My oblique asymptote, I'm going to divide x minus 3 into x squared minus x minus 2. I get x plus 2 plus 4 over x plus 2. This doesn't matter. This is what matters. Y equals x plus 2, a linear function. It crosses, my y-intercept is at 2, and it has a slope of 1. So here's my oblique asymptote. Here's my vertical asymptote. Here's my zeros. Here's my y-intercept. So I know for sure I'm in this quadrant right here, in this little triangle right here. I have to go through these and get closer. How do I know? I can't be coming from above because I can't cross these asymptotes. So I have to come from below. Crosses here and here. Alright, so when I cross this vertical asymptote, this is down. So where am I? I am up. And here I am in between these two asymptotes. So there's my graph here. Alright, so again, if I was describing it, the limit as x approaches 3 from the positive side of k of x equals, where am I going? Positive infinity. The limit as x approaches 3 from the negative side of k of x equals negative infinity, going down. If I want an end behavior, then this is going to infinity and it's going to negative infinity in behaviors. Okay? So there's that graph. Let's go over to the other board here. Hopefully that didn't make you too dizzy. All right, here's a couple more. Number 48. Again, some more oblique asymptotes. X cubed plus 1 over x minus 1. My zeros, x cubed plus 1. If I solve for x, I get negative 1. My y-intercept, again, negative 1. my asymptote, x equals 1. Well, I'm going to take my oblique, I'm going to divide x minus 1 and x cubed plus 1. So when I do that, I get x squared plus x plus 1. Well, that's a parabola. So how do I find out what my parabola is? Put it in vertex form. My negative b over 2a, negative 1/2. And my c minus a h squared is 3/4. So I have a vertex at, I didn't put this in the right place. Let me put it in the right place here. Negative 1/2. 3/4. So pretty much the same place. And continue this here. All right, so put it in the right place. All right, so see, now I have a 0 here and a y-intercept here. I know I have to be here. I have to be close to my intercept. So I'm here close to the vertical, comes through, and gets closer to my oblique. So there's that part. Cross this asymptote, I'm down, so where am I? I'm up. And so there's my graph there. All right, again, f of x, number 60, f of x equals x to the 5th plus 1 over x minus 1. So I have a vertical asymptote, x equals 1. I have a 0, x to the 5th. Solve for that, I get negative 1. Y-intercept at negative 1. So again, it's pretty much the same. All right, although when I divide to get my oblique, I get x to the 4th plus x to the 3rd plus. Now that one there's no method, so you just graph it on your calculator, find out where it's at. We find out that it's right around here. And again, I have to go through these points, very similar to the last one. Close, and then here, move up. Okay, so that is how we're doing those problems there, graphing. It's going to take some practice. Don't get frustrated. All right, it will take some practice to do that. All right, so what you're going to do, you are doing page 225. Lost my track here. Where am I at here? 1 through 43. 1 through 43, every other odd, and 51 through 61, every other odd, and Math XL 2.6a. All right, so that is your homework. All right, page 225, 1 through 43, every other odd. 51 through 61, every other odd. And Math XL 2.6a. Okay?